Torque converter dozers have ruled mining for decades. Then Liebherr built the PR776, a 70-ton hydrostatic machine claiming 20% lower fuel burn, zero brake wear, and full power through turns that stall its rivals. So, what's the catch? Liebherr positioned the PR776 directly at the apex of heavy mining when it debuted at Munich's Bauma in 2016. Industry experts confirmed the design as the world's first hydrostatically powered crawler dozer in the 70-ton class. Instead of relying on sheer weight to brute force material, the dozer prioritizes usable control. Liebherr promises that hydrostatic power provides continuous traction to both tracks, high fuel efficiency, and highly intuitive handling. For the operator in the cab, this engineering translates a massive steel frame into a responsive tool, altering how heavy material is moved on the mine face. The 24-liter 12-cylinder engine sends power directly to a high-capacity, variable displacement pump, transforming mechanical rotation into high-pressure hydraulic fluid. This pressurized flow travels through steel lines to separate oversized hydraulic travel motors tucked inside each track frame. An electronic control unit constantly monitors load demands, modulating the pump's displacement and individual motor responses in real time. This electronic modulation allows the tracks to speed up, slow down, or reverse on the fly. Because each track motor is controlled independently, the system can apply different speed commands the instant steering begins, ensuring both tracks remain fully powered. This hydraulic path completely bypasses traditional multi-ratio gearboxes and torque converters. Without physical gears to shift, the dozer achieves perfectly stepless travel with absolutely no power interruption. Scaling this fluid power package to a 70-ton class presented a massive engineering hurdle. Klaus Greiner, associated with drivetrain development, highlighted the extreme challenge of high-flow, high-pressure scaling combined with strict thermal management. Under sustained mining loads, maintaining stable operating temperatures required custom-engineered pump motor packages and oversized cooling circuits to prevent thermal failure, ensuring the dozer delivers unyielding power directly to the ground. Managing this massive fluid power is where the Generation 8's active eco mode comes in. As a standard refinement, the system changes how the dozer handles lighter work. Instead of the operator constantly adjusting the throttle, the electronic brain runs the engine at a constant, efficient speed. When the blade hits loose material, the system automatically alters the hydraulic pump's displacement to match the exact load. By scaling back output during easier tasks, the dozer limits unnecessary fuel burn compared to traditional torque converter machines, making heavy-duty operations simpler and more efficient. In a heavy mine cut, a conventional power shift dozer faces a physical limit when carving a tight turn under load. To pivot, these traditional gear-driven machines must slow or completely disconnect power to the inside track. This action instantly sacrifices forward momentum, wastes pushing force, and forces the operator to fight traction loss. The PR776 handles this challenge by independently regulating the speed of both the inside and outside tracks. When steering begins, the system actively distributes power to match the turning radius, keeping both tracks clawing at the earth. Field reports from demanding mine sites document the machine carrying massive, full-blade loads through sharp turns without stalling. As resistance fluctuates under the tracks, the speed response is instantaneous, maintaining continuous drive on both sides to keep the material flowing. Traditional torque converters inevitably lose energy as heat through fluid slip. While hydrostatic systems also have internal fluid losses, Liebherr claims its constant speed engine strategy cuts fuel consumption by up to 20%. Reported field data supports this, showing the PR776 burning approximately 38 liters per hour in eco mode. By comparison, a Caterpillar D9 under a reported mining cycle on a 15% slope, moving a 20-ton payload with a 22 cubic meter blade, consumed 45 to 48 liters per hour. But do these lower fuel rates deliver equal pushing capacity? Real-world results always depend on material, slope, blade size, idle time, and operator behavior. Ultimately, the true test of efficiency is productive work per unit of fuel. When an operator backs off the joystick, hydrostatic retardation naturally slows the 70-ton machine, eliminating reliance on traditional friction service brakes. During routine 1,500-hour inspections, maintenance crews report no measurable wear on the brake pads, though a separate multi-disc parking brake remains. By bypassing conventional gearboxes, drive shafts, and steering clutches, this design removes several high-wear mechanical components. However, fleet managers must still budget for hydraulic oil, pumps, motors, filters, and cooling lines. Ultimately, overall life cycle costs depend on the specific duty cycle, ease of service access, and specialized technician training. Conventional bulldozers rely on 3 or 4 rigid travel gears, forcing abrupt shifts that disrupt material flow and induce track spin. The PR776 replaces these fixed gear ratios with stepless speed adjustment from 0 to maximum. This continuous speed control lets operators make tiny adjustments on the fly, matching track speed to blade resistance without sudden load drops. Experienced operators note this instant feedback makes the heavy blade feel like a direct extension of the joystick during fine grading. While factors like purchase price, fleet commonality, and local service infrastructure remain key business decisions, the physical integration of continuous speed, traction, and blade placement builds a powerful operational case. As mining demands smarter efficiency, the hydrostatic shift is becoming the new standard. The PR776 proves brute force is nothing without intelligent control. Share your thoughts below.